This program highlights the relation between arrays and pointers. These are two inseparable concepts, if you ask me. Arrays and pointers are interrelated and used synonymously very often. You can pause the video and read the question. What I'll do is I'll straight away move into the explanation part. In order to solve this, let's examine the memory layout of the array given to us. So what I'll do is I'll take up the memory layout. Now there are a few assumptions that I'm going to make here. You can make your own assumptions while solving this question. Now the reason why I am going to come up with a memory layout is because it will help me to simplify the problem. If I go step by step, if I look at the position of every element, then I'll be able to understand clearly how this program behaves. This is a word of advice, you can follow it. I would recommend it. What you can do is, whenever you're given questions on arrays and pointers, try to list out the address of every element that you find. So here we have a number of array elements. What I'll do is I'll list out the address of every element and see how it varies as and when my program progresses, its execution. So let's take up a memory layout. This array is quite long. They have listed out a number of elements. So this is going to be a really lengthy array. Now while you're watching this video, I would expect you to sit with pen and paper and note down a few important points. Otherwise, it's very difficult to learn programming concepts. If you're just going to watch the video and not take down any notes, then I don't think the experience will be very fulfilling. So as I am listing down the elements, I can find that it has increased and then again started to decrease. In fact, it's restarting from 0. And there is again a 1 and a 2 and a 5. So this is the part that I won't be needing. So okay, let's just scratch it out. Here I have listed out all the elements. What I'll do is I'll also write down the addresses of every element. So every element, as you can see, this is an array. An array is a linear data structure. It is a collection of elements. It's a collection of variables where every variable is given a unique address. Now, each of these are variables, each of these memory locations, each of these array locations, and each of these array locations, since they're variables, will have a memory address. Now let's just come up with some fictitious addresses. Now arrays are storing elements in contiguous memory locations. So what will happen is I'll list out the addresses in increasing order. And I'm going to also assume that since these are integers, they are taking up 2 bytes. You may also go with the 4 bytes concept. Here I'm going with 2 bytes only to simplify my calculations. So here I'm starting with 1000. Next I'll have 1002. Then I'll have 1004. Then I'll have 1006, 1008, 1010, 1012, 1014, 1016, 1018, 1020. I know this is a bit monotonous, but this process is free from all flaws. You will not go wrong. Chances of making mistake are minimal, because if you list down every element, if you list down every address, then you will know exactly what is going on at every step of the execution. In that way, you will be avoiding unnecessary and silly mistakes. Now, after I have listed down all these elements, what I'll have to do is I'll have to examine how this program actually behaves. In fact, along with the elements and their addresses, what I'll do is I'll also list down the array indices. Then it will be easier for me once again. So these are the array indices. Remember, array indexing always starts from 0. So these are my array indices. I think I really need to work on my handwriting. I'm trying my best. I hope it's legible to you. Now, remember the name of the array. Here the name of the array that is given to us is arr. arr. The name of the array, remember, is a mnemonic. The name of the array is a mnemonic. The name of the array is a mnemonic for base address. The name of the array is a mnemonic for base address. Always keep this in mind. So since the name of the array is a mnemonic for base address, it qualifies to be a constant pointer. So the name of the array acts as a constant pointer. Now since it acts as a constant pointer, we cannot perform any arithmetic operations on it. The variable IP here, the variable IP is a pointer. See, this star here indicates pointer to, and it's a pointer to what? It's a pointer to an integer. So variable IP is a pointer to an integer, and while declaring the variable IP, we are also initializing it. That means I have a variable called IP. I have a variable called IP, and it will store some value, right? And remember, this variable, although it's a pointer, what do pointers do? Pointers simply hold memory addresses. This variable IP, it will hold a memory address. We'll see which one. Also, it will occupy some memory address itself. That means every variable, remember, every variable will occupy some memory address. Since IP itself is a variable, although it is a pointer variable, it is a variable. And since it is a variable, it will occupy a memory location as well. So it will get an address of its own. Let's assume that IP gets an address of 2000. Now, what I'm doing here is, I'm saying star IP equal to arr plus 4. What did I say? The array name, which in this case is arr, acts as a mnemonic for the base address. Now the base address here is 1000. Now if I do 1000 plus 4, what do you think? What will be the value? Is it 1004? No, it's not 1004. See, whenever you perform any arithmetic operation on pointers, it is always a scaled operation. What do I mean by a scaled operation? Here, when I say that IP equal to arr plus 4, what I actually mean is it's arr plus 4 into size of int. And why is it int? It is int because if you observe the type of IP, it is int. That means IP is a pointer to an integer. Since IP is a pointer to an integer, here the scaled operation that is taking place will be with respect to the size of an integer. Now the value of arr, as we know, is 1000. The value of arr is 1000 plus 4 into size of int. I have assumed it to be 2. So this will come to be 1008. That means the variable IP gets a value of 1008. Now since variable IP gets a value of 1008, what does it mean? See, this location, this location has an address of 1008. Since IP is holding a value of 1008, it means that IP is indirectly pointing to this location. That's what pointers do, right? Pointers hold memory addresses which indicate the memory location whose value it can give us indirectly. That's what pointers are for. See, pointer IP is holding the value 1008. Now since it is holding the value 1008, it is as if IP is pointing to this memory location 1008. That means if I am having this value 1008, it is as if I'm standing outside this memory location. I'm standing here. If I apply the indirection operator, if I apply the star operator, I'll be able to go inside. That's what pointers do. Now in the next line, what we find here is printf %d \n. This is an escape sequence for the new line character. IP of 1. Now you might be surprised to see this IP of 1. Can I really do this? We do array indexing using the name of the array. But this is a pointer, right? How can I index an array using a pointer name? The thing is, if my pointer points to an array, then I can index it using the pointer variable itself. That means if IP here, as you can see, IP is pointing to this array. Now pointing to an array means what? Pointing to an array means it is pointing to, or it is holding the address of any one of the array locations. Since IP is holding the address of this location, of the location 1008, it is as if it is pointing to the array. Now since it is pointing to the array, it can index the array just like it would have, or just like we would have indexed the array using the array name. Therefore, this statement is perfectly alright. Remember, if a pointer is pointing, it's very simple. If a pointer points to an array, then we can index the array using the array name as well as the pointer variable. So here we can index the array arr using arr itself, the conventional way, and we can also index it using the pointer variable. Now the thing is, how does the index work? Now you might wonder that IP of 1, okay, since this pointer is pointing to this array, and if I index on it just like I would index the array name, then IP of 1 would give me this location. But the thing is, IP of 1, or in fact even if you do arr of 1, the internal calculation that takes place is not so simple. That means IP of 1, see, IP of 1 will be evaluated as IP plus 1 into size of int. Again, why size of int and not size of float? Because IP is a pointer to an integer. Now the interesting part is the value of IP is 1008. It's not 1000. I hope you're getting my point. Had IP been pointing to the first variable, then it would have had a value of 1000 and we could have had this value at 1002. But the thing is, IP is not pointing to the first element. IP is pointing to the element at index 4. As a result, the value of IP will be substituted here. The value of IP is 1008 plus 1 into size of int. What is the value of size of int? I have assumed it to be 2. So 1 into 2 will give me 2. Adding it with 1008 will give me 1010. So if I get 1010, remember, this entire operation, it will be dereferenced using the asterisk operator. I am going to dereference this location. That means by 1010, I am standing here. This is me. I am standing here. Now if I apply a star, I'll be getting inside. So if I get inside, the value that I'll get is 6. The value as a result that will be printed will be 6. 6 will be printed. So I hope you understood this part. See, you might be asking me that can I make this arr variable, which is a constant pointer, can I make it point to this? Can I start from this location? I cannot. Why? Because I cannot change the value of the name of the array. The name of the array doesn't hold any value as such. It's simply a mnemonic for base address. Remember, it is a mnemonic for base address. So it doesn't hold a value as such, but I cannot perform, like I mentioned right at the start of the video, that I cannot perform any arithmetic operation on the name of the array because it is a constant pointer and constants are not supposed to change during the execution of the program. So if I do something like this, if I do arr equal to arr plus 4, this is wrong. This will not be evaluated in this manner. These two are different. Why? Because IP is a pointer variable and arr is a pointer constant representing the base address. So this was a long video. I touched upon a number of points. I hope you have understood. Even then, if you have any doubts, please feel free to comment. I'll discuss or I'll try to explain and clarify your doubts as far as I possibly can. So I hope this helps. Thank you.